In this episode, we're going to connect ethics to AI security work in a way that feels concrete and practical, because ethics can sound like a vague topic until you see how quickly it turns into real business risk. When AI systems influence decisions that affect people or money, ethical failures are not just embarrassing. They can trigger legal action, regulatory scrutiny, loss of customers, and long-term damage to trust. That is why ethical principles show up in AI security management, not because security teams are trying to be philosophers, but because ethical harm is a form of risk that organizations must manage. If an AI system denies someone a job unfairly, exposes private information, or produces misleading recommendations, the organization can be held accountable even if there was no traditional hacking event. The exam expects you to recognize when ethical concerns are part of the risk picture and to choose actions that make outcomes more fair, transparent, and defensible. By the end, you should be able to explain what ethical principles are in this context, why they matter for security management, and how to apply them in decision-making without getting stuck in abstract language. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good starting point is to understand what we mean by ethical principles in AI, because the principles are really about preventing harm and maintaining trust. Ethical principles commonly include fairness, accountability, transparency, privacy, safety, and reliability, and each one can map to a specific type of business risk. Fairness is about avoiding unjustified differences in outcomes for different groups of people, especially when those differences affect opportunities or access. Accountability is about ensuring someone owns decisions and can explain them, rather than blaming the system. Transparency is about making the system's purpose, limits, and decision logic understandable enough to support oversight and trust. Privacy is about respecting personal information and limiting misuse or exposure. Safety and reliability are about preventing the system from causing harm through incorrect or unstable behavior. Beginners should notice that these principles are not separate from security, because security is ultimately about preventing harm to the organization and the people it serves. Fairness is often the most discussed ethical principle in AI, and it becomes a security management issue when unfair outcomes create legal or reputational risk. An AI system can be unfair for many reasons, such as biased training data, incomplete data, or design choices that indirectly disadvantage certain groups. For example, a hiring system might learn patterns from historical hiring decisions that were biased, and then repeat those patterns at scale. A lending system might rely on signals that correlate with protected characteristics, even if the model is not explicitly given those characteristics. Beginners sometimes assume fairness is only about intent, but in risk management, fairness is about outcomes and impact. This is why governance often requires impact assessments and testing that look for harmful differences across groups. The goal is not perfection, but reducing risk by identifying unfairness early and documenting mitigation steps. When exam questions describe high-impact decisions affecting people, fairness principles become part of a defensible security management approach. Accountability is the ethical principle that often turns into the most practical governance requirement. If an AI system produces harmful outcomes, the organization cannot shrug and say the model did it, because the organization chose to deploy it, chose the data, and chose how it would be used. Accountability means decisions have owners, and those owners are responsible for ensuring requirements are met and for responding when things go wrong. This includes accountability for monitoring, change control, and documentation, not just the initial build. Beginners should understand that accountability is what prevents blame shifting, which is a common failure mode when AI behaves unexpectedly. In mature AI governance, accountability is reinforced through clear roles and responsibilities, decision records, and approval checkpoints. Exam questions that ask what makes an AI program defensible often point toward accountability structures and evidence, because accountability is not just a moral concept, it is an operational requirement. When accountability is clear, the organization can act quickly and consistently to reduce harm. Transparency is another principle that can sound abstract until you connect it to real-world demands. Transparency in AI does not always mean revealing every internal detail of a model, because that may be impossible or inappropriate, especially with vendor models. Instead, transparency means people can understand the system's purpose, limits, and the kinds of inputs and outputs it produces. It also means that when the system influences important decisions, there is enough explainability and documentation to support review and challenge. For example, if an AI system helps prioritize fraud investigations, transparency includes knowing what factors influence the prioritization and how errors are detected. If an AI system generates customer messages, transparency includes knowing that the output is generated, what guardrails exist, and how the organization checks for harmful content. Beginners should see transparency as part of trust, because people will not trust a system they cannot understand at all. In security management, transparency supports oversight, which reduces the risk of hidden failures becoming public incidents. Privacy is a principle that becomes immediate business risk when AI systems process personal data or reveal sensitive information through outputs. Privacy risk can come from collecting too much data, using data for purposes people did not expect, storing data too long, or allowing the system to output personal information. AI systems can also create privacy risk through inference, meaning the system reveals patterns or details that were not explicitly provided in the input. Beginners often think privacy is only about keeping data secret, but privacy also includes respecting rights, minimizing use, and controlling what can be generated. In governance, applying privacy principles often means requiring data classification, limiting access, enforcing retention rules, and monitoring outputs for sensitive content. It also means being clear about what data is allowed to be used in training or tuning, and what obligations apply if personal data is involved. Exam questions that mention customer data, employee data, or regulatory obligations often expect you to apply privacy principles through testable controls and evidence. Privacy is not just about being careful, it is about building systems that can be shown to respect boundaries. Safety and reliability principles often show up when AI systems can cause harm through incorrect, unstable, or misleading outputs. An AI system can be unsafe if it produces dangerous recommendations, creates false confidence, or fails in ways that are hard to detect. Reliability matters because even small error rates can become serious at scale, especially when the system influences decisions repeatedly. Beginners should understand that reliability is not only technical accuracy, it is also consistency of behavior under normal use and under stress. Applying these principles usually involves testing, validation, monitoring, and clear escalation paths when behavior deviates from expectations. It also involves defining what unacceptable behavior looks like, such as outputs that contain sensitive data or outputs that violate policy. In AI governance, safety and reliability are maintained over time through periodic review and controlled change management, because model behavior can drift. Exam questions that involve unexpected outputs or degraded performance often point towards safety and reliability principles implemented through ongoing monitoring and validation. Now let's talk about how to apply ethical principles in practical decision-making, because the exam expects action, not just values. Applying principles starts with identifying where the system's outcomes matter, meaning who can be harmed and how. That includes direct harm, like denying someone an opportunity, and indirect harm, like eroding trust through misinformation. Then you translate the principle into requirements and tests, so it becomes something you can verify. For fairness, that might mean testing performance across groups and documenting mitigation if differences appear. For transparency, it might mean requiring documentation of purpose, limits, and how humans can review decisions. For privacy, it might mean restricting data use, enforcing retention, and monitoring outputs. For accountability, it might mean assigning an owner and requiring decision records. Beginners should remember that principles are not controls, but principles guide what controls must exist. The exam often rewards answers that show this translation from principle to testable requirement to evidence. A key beginner skill is recognizing common misconceptions that lead to ethical risk. One misconception is assuming that removing certain sensitive fields from data automatically makes the system fair, when in reality other variables can act as proxies. Another misconception is assuming that a system is ethical if it is accurate on average, when in reality average performance can hide poor performance for specific groups. Another misconception is assuming transparency means dumping technical details, when transparency in governance is about clear documentation and explainability appropriate to the context. Another misconception is assuming that ethics is separate from security, when ethical harm can become a security incident in the sense of business impact and accountability. A final misconception is assuming a vendor system is the vendor's problem, when the organization still owns the decision to use it and must manage risk. These misconceptions show up in exam distractors, where answer choices sound comforting but do not actually reduce risk. When you spot a misconception, you can eliminate weak answers more confidently. Ethical principles also connect strongly to human oversight, which is the idea that humans remain responsible for important decisions and can intervene when the system behaves poorly. Human oversight does not mean humans must do everything manually, but it does mean there are clear ways to review outcomes, challenge decisions, and correct errors. For high-impact uses, oversight may include review steps before decisions are finalized or audits after decisions are made to detect patterns of harm. Oversight also includes training users so they understand the system's limits and do not treat outputs as guaranteed truth. Beginners should see oversight as a safety net, because AI systems can be confidently wrong, and people can be tempted to accept outputs without questioning. In governance, oversight is supported by access control, logging, monitoring, and escalation routines, because you cannot oversee what you cannot see. Exam questions that involve high-impact outcomes often reward answers that include oversight and monitoring rather than blind automation. Oversight is part of making ethical principles real in daily operations. Applying ethical principles also requires clear communication, because trust depends on people understanding what the system is doing. Communication includes explaining to stakeholders what the system is for, what it should not be used for, and what safeguards exist. It also includes communicating with leadership about trade-offs, such as when increasing automation could increase risk in a high-impact domain. Beginners should understand that communication is not marketing, it is governance, because it shapes how people use the system. If employees think an AI assistant is approved for all data, they will feed it sensitive information, creating privacy risk. If customers think outputs are human-reviewed when they are not, trust can be damaged when errors occur. Governance programs often require labeling, guidance, and clear acceptable use expectations to reduce misuse and confusion. Exam answers that include clear guidance and defined boundaries often align better with ethical risk reduction. Ethical principles are easier to apply when expectations are communicated clearly. As we wrap up, applying ethical principles in AI security management is about recognizing that harm can happen through outcomes, not just through hacking, and that harm becomes real business risk. Fairness, accountability, transparency, privacy, safety, and reliability are principles that guide what controls must exist and what evidence must be maintained. The practical approach is to identify where outcomes matter, translate principles into testable requirements, validate through assessment and monitoring, and maintain clear ownership and oversight. Beginners should focus on the idea that ethical principles become actionable when they are connected to governance routines like approvals, documentation, change control, and periodic review. Exam questions in this area often reward choices that make the organization defensible, meaning it can explain what it did, why it did it, and how it knows it worked. When you can connect ethics to controls and evidence, you are not treating ethics as a separate topic. You are treating it as part of responsible AI security management. That is exactly what Task 3 is asking you to do.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.